Welcome back, guys, and today I'm going to talk about different proof strategies. There are basically three proof strategies. The first one is direct proof. The second one is proof by contradiction. So proof by contradiction. And the final one is proof by contra-position. So there are basically three proof methods, strategies. So I'll be going through each one. So let's start with the first one, direct proof method. So in direct proof method, I guess you guys can understand it by the name. You direct with the information that you have. You try to prove the statement or come to a conclusion. So suppose someone says for n plus 2 equals to 6 if n is 1. So with your basic geometry knowledge, you put 1 here and plus 2, this equals to 6. So this is proof. So using the information that you have and with your general knowledge of algebra, you can directly prove this statement asked by your question, right? So let's move on. So the next one is proof by contradiction. So in proof by contradiction, we try to prove that the opposite or the inverse statement, so the opposite or the inverse statement is wrong, thus proving the actual statement is true. So suppose we have a statement P and we have another statement Q. So it was telling us that if P is going to happen, then Q is going to happen too. So this is a statement which is we have to prove that this is true, right? So in proof of contradiction, proof by contradiction, we inverse the statement. So not P equals to not Q, and if this is false, this means that the original statement that P equals to Q is true. So let's try to understand this with an example. Okay, so let there be a statement that if it's 30th Ramadan, then Eid is tomorrow. So here we can see there are two separate statements. If it's 30th Ramadan, let's say this is P, and then Eid is tomorrow, let's say this is Q, right? So it and the question asks prove that this is true. So so let's say this is true, and we are trying to prove this using proof by contradiction. So let's try to do that. So not P would be it's not 30th Ramadan. Let's say this is like 29th, and not Q would be Eid is not tomorrow, right? So this is false because even if we like see the moon on the 29th, then it's going to be tomorrow, right? So this statement becomes false. So not P, not Q, it would give us a false result, thus making the original statement P would P implication Q would be true. So hope you guys understood that. Let's move on to the third one, which is proof by contraposition. So in proof by contraposition, or we have to remember two things. So positive statement is a combination of two things. One is the statement has to be inversed, same as before, and it has to be conversed. So what do I mean by that? So let's assume we have a statement P again and another one Q. So P is P implicates P implication Q. So what would be the contra positive statement? It would be, we would inverse it first. So P implicate, not P implication, not Q, and then we would converse it. We would swap the places. So if we can prove that this statement is true, then the original statement would also be true. So this is different from proof by contradiction, because here we, after changing the whole statement, we try to prove that it is true. So if this is true, the original statement would be true. So let's look at an example here. So let the example be, if 3n plus 2 is odd, then n is odd. Right. So let's assume that this is P and this is Q. So if you want to prove this by proof by contradiction, if you want to prove this using proof by contraposition, then we'd have to first inverse them, then change places. So Q and P. Okay, so not Q means n is even, and not P means 3n plus 2 is even. Right? So let's try to go into the mathematical part here. So 2n is even, right? So then n equals to 2k, where k is any real number. So if you try to do 3n, then it becomes 6k, right? Makes sense. And 3n plus 2 becomes 6k plus 2. Now we can take 2 common, so 3k plus 1. So this portion, this whole thing is a odd number. So this whole thing is an odd number, and if you multiply anything with an odd number, you would get an even number. So for example, If the odd number is 7 and you multiply it with 2, it would be 14. And again, same 9 with 2, it would be 18. So the number that we get would always be even. So this is a positive number, even number, and the result that is being generated, it's also an even number. So even is equal to even. Thus not Q implication not P is true. So as I said before, in proof by contraposition, if the change statement is true, then the original statement P implication Q would also be true. Well, hope you guys understood everything. Thank you for watching.